Okay. So good afternoon, everyone. I welcome all of you to this live session of the microwave engineering course, which is actually going through, I think, 5th rerun. So it is a core course, and we try to cover all the basic details that are needed for an undergraduate microwave course. For this session, we have the TAs for the course, Mr. Shashank Srivastava and Shurabhi Mishra. So they are helping me out in running this course. So we are into the 8th week, and every week we are putting the assignments covering the course content that you see in the video lectures, and we try to keep the assignment problems to such a level that it gives you enough confidence to solve the microwave engineering related problems. We have in this course a comprehensive coverage on the microwave theory and technique. We start with the basics of transmission line, then we discuss waveguides, Smith chart, impedance matching, design of the impedance match, power dividers, microwave filters. Then we have discussions on active microwave components also. We discuss tube-based systems like klystron, magnetron, TWT. We also discuss the solid-state microwave devices, microwave transistors, and then how to design amplifiers. We talk about the microwave control circuits, how to design circuits using pin diodes, the detection of signal using microwave detectors, detector diodes. And apart from that, we also discuss in this course different application of microwave engineering. As you know, microwave engineering or microwave concept, these frequencies are used in a wide variety of applications involving today's cellular phone. So we briefly discuss about this application in the cellular phone. We discuss application of microwave in radar. We have also discussed the industrial application of microwave very briefly, particularly microwave heating, and one or two biomedical application of microwaves. So in that sense, the course give a comprehensive coverage of different aspects of microwave engineering, starting from the very basics of the transmission line theory and going to the industrial application of microwave. And the content has been designed using very standard books which are follows worldwide. The books by D.M. Poser, R.E. Collin. So those reference standard books have been used as a reference in designing the content for the course. Also, the tubes and active circuits, you can look into microwave engineering by Liao, Samuel S. Liao. So these books are very, very standard, and these are used worldwide. I was going through the Google Sheet that was circulated requesting questions from the learners. So only one learner actually has asked a question. and this is regarding the design of the power divider using microstrip lines. Power division, as we have discussed in the theory, suppose you are going for a 3-port power divider. So a 3-port circuit, it cannot be simultaneously lossless, matched at all 3 ports, reciprocal, matched, and lossless. So if you try to design any power divider and want to match at all ports, either it has to be lossy, but one particular design which is very popular, it is Wilkinson power divider. We have discussed in detail in the course video. It uses a resistive divide between the 2 ports, but that resistance only remains floating and therefore does not dissipate any power if there is no imbalance in the circuit. So this particular design is used almost all throughout. It consists of transmission lines and resistance. Comes to microstrip based power divider design, the transmission lines we need to use microstrip lines. And as you know that the microstrip lines, these are planar lines. We will have one ground plane, on top of it some substrate, and on top of this the line which is etched out from copper. So in microstrip line, the impedance, characteristic impedance of the line is decided by the thickness and the width of the line. We call W by H. Wider the line, lower is the impedance of the line. Thinner the line, it will give you higher impedances. So depending upon the impedance values and the substrate that we are using, based on the thickness of the substrate, we can choose the width of the microstrip line. Now, there are some limitations to what level of impedances can be, or characteristic impedances can be realized using microstrip lines. Usually, if you make it less than 20 ohm, or if you make it more than 120 ohm, both the cases it is avoided, because more than 120 ohm means the line thickness become very small, and if you use less than 20 ohm, the line becomes very thick, and the section of the line, instead of guiding the waves, chances that it will radiate also. So usually when we use microstrip configuration for design of the circuits, the impedance values are kept between these two limits. Now, when you design a power divider, suppose you design a Wilkinson type power divider or a T-junction power divider, you first determine the impedance of the lines that are required, and then these impedance values are realized using suitable section. Usually, if it is Wilkinson power divider, we use lambda by 4 sections. So at the operating frequency, you will have to find the guide wavelength. Now, this guide wavelength or the microstrip wavelength, this is different from the wavelength if the strip has been in homogeneous dielectric media. This is because in microstrip configuration, we have below the line we have a dielectric and above the line we have air. So we talk of effective dielectric constant. So first you will have to find out effective dielectric constant, and then there are designers available for microstrip lines, or we have microstrip line synthesis equation also using. Then you will have to write some code, and then you will have to or use a do long calculations to find out the W by H that is needed for realizing the microstrip line of the given impedance. And then the substrate thickness and dielectric constants are decided earlier. So if you are designing at say low frequency using FR4 type of substrate, then you will have a dielectric thickness normally about 1.6 mm and a dielectric constant of roughly 4.4. So these values are to be obtained from the data sheet. And then you calculate the effective dielectric constant. Then you calculate the width of the line needed to realize the desired impedance. And then use this line to design the power divider circuit. Usually you will find that some bending has to be given when the junction is formed, and this, if you make very sharp bend, there are chances of radiation. So there also chamfering and other things has to be done. And then when the pattern is etched out, then you will have to drill holes connecting the type of connector that you want. Suppose you want SMA type of connector, then the central conductor, you will have to make it through the substrate and connect to the upper line, and bottom conductor, you will have to bottom conductor or the outer jacket of this coaxial connector has to be connected to the bottom conductor. So in that way, you can fabricate and then you can test it using the network analyzer or other form of devices. Power dividers using microstrip lines are usually not very broadband because of the fact that microstrip designs are valid only nearby close frequencies of the design frequencies. Otherwise, you will have to take the dispersion into account. So this is in nutshell how we utilize the microstrip, how we utilize microstrip line in designing a power divider. I hope the learner, you get some idea about how it is done. Resistances and other things, if the frequency is very high, we have chip resistances. These chips are to be shouldered, so that engineering part or how you do the machining and how you do the fixing, those are require some amount of skill. So in general, I should say that we have taken every care to see that our students registered in this course, every year we get a good number of registration in this course, and also around 300 to 400 students that take the final test. So if there are no other queries from the participants there, Shashank, any other queries there in the Google Sheet?
No, sir. There is no query.
Or in the chat box, anything is there?
No, sir.
So we can wish good luck to the people who will be taking test in the end of October. We have already covered, so out of it is a 12 week, 8 week, so 2/3 has been covered, and the assignments, everything are being posted. I hope you are doing those assignments regularly. This will give you an idea about the final examination, to what depth you need to study. And every time we take care that the questions are not repeated, we try to set as many fresh questions as possible in the assignment problems, so that every time you are solving these questions, you get to know the subject in a better way. So please keep us posted, and if there are no queries, no other student is coming forward with a query, I think we have discussed about the course. We have answered one query that we received, and wishing good luck to the students. We can wind up this session.
Sir, thank you.
NPTEL team,
Thank you,
please.
sir.
Okay.